This conference will now be recorded.
All right. So to begin, in the yesterday's class, we started with the programming. So we had to configure the I2C block. So the first thing what we did coming into the main function here is, so I had to do the initialization. So I called the init config function. Then in the init config function, I have to do the initialization of the I2C. So the baud rate is 100K. I'm passing 100K as an argument. So control comes to the function's definition here. We did few initialization. One was to set the I2C into the master mode. The other one was to write the baud rate, whatever baud rate we had, the corresponding baud rate had to be returned into the address register. So that baud rate we wrote it into SSP ADD by calculating it using this formula. Then SSP EN, this is to enable the serial port. So that initialization we did. We wrote few functions whenever I have to do the check of if the bus has been idle or not. I should be calling I2C wait for idle function. So this is where I'm going to check if the bus has been idle or not. And in order to do the start, in order to pass the start condition, I just have to make SEN bit a 1. So before that, I'm checking if the bus has been idle or not. So if it is repeat start. So in our case, it is like this. So it is, I just have to make RSEN a 1. Okay. Then it is, in order to stop, I'm checking if the bus has been idle or not, and I just have to make PEN a 1. So that is what we did. The very small functions, two-line functions for the start condition, stop condition, repeat start, and the wait condition. Then whenever I have to write using the I2C write function, so whenever I have to write, so me being the master, if I have to write using the I2C write function, so I have to have the data with me, whatever I have to write. So I just have to write the data into the buffer register and wait until I receive the acknowledgement. Then coming to the I2C read function, so I have to be reading. So in order to read, I will check if the bus has been idle or not. I make sure RCEN has been made one, that is when you are ready to receive, and then you have to just check if the bus has been idle or not and read the buffer data into the data variable. Then there is an acknowledgement. Depending on the requirement, acknowledgement has been sent, and then the data will be returned. So we did the initialization of I2C in yesterday's class. Now we are left with the initialization of RTC. Okay. So and the IC's name is DS1307. So if you look into the main function, after I initialize the I2C, I have to be initializing the RTC. So it is DS1307. Okay. So DS1307 is the RTC. So I have to do the initialization with respect to the RTC. Now let's begin the initialization. So to start with the initialization of RTC, there is nothing difficult actually. So basically what and all requirements are required for the RTC is already done. Okay, so you don't have to be doing any initialization as such with respect to the RTC. So remember, this RTC is something which is maintaining the time, not just the time, it is maintaining a few other things as well. It also maintains the calendar along with the time. So we have to understand this and then do the initialization. Let me guide you of how to do the initialization with respect to the RTC. Now, can you tell me, if I have to do the initialization with respect to RTC, should I go with the same data sheet what we were using so far? Should we be going with the same data sheet? So we were referring the data sheet of PIC 16F877A. Should we be going with the same data sheet is my question. Come on guys, should we be going with the same data sheet? Why is a yes? Same data sheet. So how are we making the communication? This is the PIC microcontroller. This is the RTC. So am I going to do the same same data sheet. The data sheet I kept referring was with regards to the PIC microcontroller. So is the RTC present inside the PIC microcontroller itself? Is the RTC present inside the PIC? No. So that's a different one. So you have to refer the data sheet of the RTC, which is DS1307. Okay, so this is the data sheet to be referred in order to do the initialization with respect to the RTC. Now, if I have to open and show you, this is actually a very small document. It's a document of 15 pages only. And I am assuming none of you have ever opened this data sheet ever before. Okay, so let us start with the initialization of this RTC. So what actually happens is, as I said, basic initializations are all done. RTC is a hardware which is communicating with other devices using I2C protocol itself. So there are no other ways of communicating with the RTC. So any microcontroller wants to communicate with RTC, it has to be communicating using the I2C protocol itself. So basically, what and all initializations needs to be done is already there. So things are already initialized. I just have got one small thing to be done. Somebody's mic is on. Prakash, he's giving his house stories. Prakash, you there? What plans are you giving us, man? And basically, whoever can understand Kannada has got your house plan, anyways. All right. So yes, let's continue. He muted it by himself. Okay, fine. So I was talking about DS1307 RTC. So it is a serial real-time clock. So remember, it is a low power full binary coded decimal. Okay, so remember, it's a low power device which is whose data is been in the form of binary coded decimal. And remember, the clock or the calendar is also stored. So there is clock information stored, there's calendar information also stored. And also remember, the device has got SRAM inside it, which is of 56 bytes. Okay, so it has got an SRAM which is of 56 bytes. And apart from that, remember, this RTC is going to provide us the information regarding seconds, minutes, hours, day, date, month, and year. And also, if there are several months who have got less than 31 days, some adjustments, some corrections are done. So if there is any leap year, so that corrections are also done. And in terms of clock, it can give you information in 24 hours format or in 12 hours format also. And if you are going with 12 hours format, it will tell you whether it is AM or the PM. Okay, so all these informations are being present inside the RTC itself. So you just have to read the content from the RTC. If you want to know this information, you just have to read. If you want to do some changes, you just have to write. Okay, so that is about the RTC. And another advantage is it can be separately battery backed up. And as I maybe you must have already known that this RTC is using very less power. Okay, so comparatively, so whenever there is power failure detected, it switches to the battery power supply and things happens normally. Now, if you read further, if you want, you can go through it. It is a very small document. As I said, it's just of 15 pages. You can go through everything whenever your time permits for you people. So let me proceed. I am jumping to the required part only. So I want to go with the default settings. So all default settings are all done. There is one small thing I have to do with respect to the halt bit. There is something called as halt bit. So I have to do things with respect to that. So I'm just scrolling down to go with that. Okay, so now here, if you can read, the time and the calendar information is obtained by reading the appropriate register bytes. Okay, so I gave you a fair idea in yesterday's class saying that the address has been means the RTC has got several registers in some addresses, and data is being stored inside it. Okay, for example, seconds in address 0x00, minutes in address 0x01. These are the registers name. These are the addresses where the registers have been found. Okay, so relatively the same thing has been given here as well. So the time and the calendar information, whenever you need, you just have to be obtaining it by reading the appropriate register bytes. So table 2 shows the registers, the RTC registers. So let me show you which is that. This is table 2. Okay, and this is telling you the information regarding the registers of the RTC. So remember, there are these functionalities which are being stored inside the RTC. There's second, there's minutes, there's hour, day, date, month, year, control, everything. So seconds has been present in the address 0x00, minutes is present in the address 0x01, hours in the address 0x02, day in the address 0x03, then date, then month, year, everything. Okay. So as of now, I am concentrating only on the date. Sorry, the time. Okay, so I am concentrating only on time, so I have to be focusing only on seconds, minutes and hours. Okay, so whenever I want to get the data corresponding to seconds, read the address 0x00. If I want to get the data related to minutes, read the address 0x01. For hours, it is 0x02. Okay, now as I said, appropriate registers are there. You just go into the register and read. So if it is seconds, the data you might get is ranging from 0 to 59. If it is minutes, the data is ranging from 0 to 59 again. If it is hours, see, bit 7 is fixed to 0. Bit 6 is to tell whether it is in the 12-hour format or it is in the 24-hour format. Okay. If it is in the 12-hour format, this bit is going to tell me whether it is AM or PM. If it is 12-hour formats, this bit is going to tell me whether it is AM or PM. And means if it is 24 hours format, all the 5 bits here will be used to store the address. Means the hours. Okay, so 1 to 12 is the hour, AM or PM will be stored in the next bit, else 0 to 23 if it is a 24-hour format. Okay, so these are the things. Similarly, if you want, you can read the calendar related information as well, as the day, date, month, year, whatever you want, you can read it. Okay, now if I come back here, it says the time and the calendar are set or initialized by writing into the appropriate register bytes, which I just said. Contents of the time and the calendar in the registers are in the BCD format. You should not be forgetting this. Any data present inside these registers are in the BCD format. The day of the week register, the week related information I don't actually need. Okay, so let me ignore it. Illogical time and date entries result in undefined behavior. That is normal. Also, bit 7 of register 0 is the clock halt bit. What does it say? Bit 7 of the register 0. So this is register 0. Okay, the very first register. Bit 7 of it is the clock halt bit. You can observe it is CH. It is the clock halt bit. Remember, when this bit is being set to 1, the oscillator is being disabled. When it is cleared, the oscillator is being enabled. Okay, so usually what happens is when the system has been just turned on, you read the note here, initial power on state of all the registers is not defined, therefore it is important to enable the oscillator during initial configuration. So whenever the RTC has just been turned on, it will not have the valid information inside it, and that happens only when you make CH a 0. Okay, because see here, CH bit, if you are making it a 1, then oscillator is been disabled, and CH is 0, oscillator is been enabled. I have to make sure oscillator is been enabled. Okay, I just have to write CH with the value 0. Okay, only thing I want to write is CH with the value 0. Now, whenever I have to write, okay, whether it is me who have to write, me in the sense it is the microcontroller who wants to write. Okay, he wants to write CH with the value 1 to the RTC. RTC is a separate chip. Okay, to the RTC, CH has to be written with the value 1. So whenever I have to write, what will I do? Whenever microcontroller wants to write, what will he do? Come on, whenever I have to be writing, what should I be doing? We wrote some function yesterday, if you have not forgotten. So we are supposed to call I2C write function, isn't it? Yes or no? I have to write I2C write function whenever I have to be writing. So this time I actually want to write into the RTC. Okay, so I want to write into the RTC. Definitely it is by using the I2C write function itself. So whenever I want to write, let me call a function DS1307. So this is the IC's name. I'm going to call the write function. Okay, so to the write function, I should pass the address in which I want to write and also the data I want to write. Okay, so to the DS1307 write function, I should be passing the address where I want to write and also the data I want to write. Okay, now tell me, in which address should I be writing? In which address should I be writing? See here, so I should be writing it into the seconds register. CH is a bit which is been in the seconds register. Okay, CH is a bit which has been in the seconds register. I want to write into 0x00. So what will I do here is I will call DS 1307 underscore write. So I'm calling the function by passing the address 0x00 and the data I want to write. Let's say I pass 0 as an argument to be written into 0x00. What happens? I'm passing 0 as an argument to be written into the address 0x00. How many bits am I writing? How many bits am I writing? Come on. So I want to write, I'm passing DS1307, write 0x00 and 0 I'm passing. To the address 0x00, I'm telling to write 0. How many bits am I changing? Come on guys, how many bits are we changing? Don't you think I end up changing 8 bits? Yes or no? Am I not changing all the 8 bits? And is this correct? Is it correct to change all the 8 bits? So see here, unnecessarily I'm changing all this 7 bits also. This 7 bits is actually having the seconds related information. Is it good to change all the 8 bits? No, I have to change only the 7th bit, the MSB bit only. Okay, so what I will do here is, this 0x00 is the address of the second register. So I'll take a macro here, as define second register's address is 0x00. Okay, so then I'm calling the DS1307 write function. I'm passing the second register's address. So something like this, second ADDR. So passing 0 is wrong because I'm going to change all the 8 bits. So what I will do here is, instead of changing all the 8 bits, I have to change only 1 bit. Okay. For that, first thing I will do is I'll take a variable called dummy. Okay, I'll take a variable called dummy. And from the DS1307 IC, I'm going to read from the address 0x00. Okay, or let me say it as second register's address. Okay, so I'm calling DS1307 read function, means I'll go to the address 0x00. I will read 8 bits. So that 8 bits is being stored inside dummy. I just want MSB to be made 0. How can I do that? Have to make only MSB 0? Okay, so is that some of you are saying 0x00 and with 0x7? Yeah, why is that? 0x00, guys, it's the address. Okay, it is the address. You should not be adding the address. So do you people agree doing dummy and with, sorry, Duffy I wrote, I'm very sorry. So dummy and with 0x 7, yeah, do you people agree with this? And I write it back to dummy, correct? So let's say initially dummy had some value like this. Maybe xx, I'll copy this. Oh shit, just a minute. Okay, so let's say initially it had some 0x, all x like this. Let's say I'm and with 0x7 here. So this has to be 1, 1, 1 and 1. So this ends up getting x, and this also ends up getting x. So now, do you agree that I retained the rest as it is and I have changed only the 7th bit? 7th bit I have made 0. Is that right? Guys, is it correct? Did we make only 7th bit 0 doing dummy is equal to dummy and with 0x7? Yeah. Do you people agree? See, I just have to make the 7th bit. The CH has to be made 0 because to turn on the oscillator, I have to make CH a 0. So if I have to make CH a 0, the rest 7 bits I have to keep it as it is. So how did I do? I read the value from the seconds register. I got all the 8 bits. Out of that, only one bit I'm making a 0. So by ANDing it with 0x7f, then I'm going to write it back using this ds write function. So here, what I will be passing is, what should I be writing here? To the second register's address, what should I be writing? Using the ds1307 write function, to the second register's address, what should be written? Come on, please respond. Yes, so I just have to write the value of dummy, isn't it? Do you people agree that I should be writing the value of dummy into the second register? Everybody, do you people agree? Okay. So that's right. I have to be writing the value of the dummy variable like this. So that is the same thing we have done here in the initialization function. You observe. So I have taken a variable called dummy. So there is read ds1307 function. So I'm passing the address of the second register. This is a macro. Second address is a macro which is been initialized with, let me show you, 0x00. Okay, you can see here second register's address is 0x00, minute register's address is 0x01, hour register address is 0x02. So that is what I'm doing here. I'm reading from the second register's address into a variable called dummy. I made dummy and with 0x07. Then that value of dummy, I wrote it back into the second register by the function write ds1307. That is how I just made ch a 0. And that is the only initialization to be done. Understood? Are you people clear with this, everybody? Okay. So let's proceed then. Now, just because I have used now just because I have used read ds1307 function, I should be knowing the definition of the function. So how the function is actually been working. So to understand that, let me show you this function's definition. It is ds1307's read function. Okay, and then it is the write function. Now let me go with the write function first. Okay, let's say me being the master wants to write into the RTC. Okay, so what is the thing I want to do? Me being a master want to write into the RTC. First thing, I want to write into the RTC. Actually, into some address. So either it is the second register's address or the hover register's address, whichever I want to write. So now master wants to write into the RTC. Operation has to start. First, I have to check bus has been idle or not. See the thing here. That is what I have done. Okay, I must have not done it. So I have to check if the bus has been idle or not. So for that, I haven't written it. Let me copy paste the functions call. I2C here. Okay. So here, I have to check if the bus has been idle or not first. So I come here. I'll check if the bus has been idle like this. After I check the bus has been idle or not, sorry. Okay. After I check the bus has been idle or not, the next step is I have to do the start condition. So that is what I did. I have called the I2C start function. So I called I2C wait for idle. Then I'm calling I2C start function. Then the next thing is I have to tell, means I have to transmit. See here, the master has to transmit the unique address along with the intention. Okay, what is the next step? Master has to transmit. Okay, let me write it here. So here master has to write. Okay, and this is written by the slave anyways. Again, to pass the second register's address means it is the write operation itself. And here is the read operation. Okay, now let me tell you. So first I have to pass the address along with the intention. Okay, I have to call the I2C write function. I have to transmit the unique address along with the intention. Now, do you people know what is the unique address of the RTC? Do you people know the unique address of the RTC right now? Did we ever see the unique address of the RTC? Come on, guys. Unless you're not responding, it is literally difficult for me. And if the same thing happens in the project as well, that will be difficult for both of us. Okay, so we don't know what is the unique address of the RTC. So right now, we have to search for the unique address of the RTC. So RTC has actually got two types of unique addresses. Usually, unique address can either be 7 bits or it can be of 10 bits. Okay, it is up to how the slave has been designed. So it can either be 7 bits or it is 10 bits. Let's see how much is that in case of RTC. I'm just scrolling down. I want to search for the unique address of the RTC. So I have kept scrolling down. Okay, so here, slave receiver mode. If you can notice, mm, serial data and clock are received through SD and SCL line, which is all fine. So you can see here, the slave address byte contains the 7-bit DS1307 address, which is 11010000. So this is the 7-bit address, unique address of the RTC. So let me note it down here. It's the unique address. Okay. So unique address of RTC. So how much is the length? It is 7 bits. Okay, the length is 7 bits. And what is that? It is 11010000. So 11010000. So this is the unique address of the RTC. Along with the unique address, I have to pass the intention, whether it is read or write. So let me show here, followed by the direction bit read or write, which for a write is 0. So write means 0, read means 1. Okay. So 8th bit is intention, read or write. Okay. So it is 0 for the write operation and it is 1 for the read operation. Okay. So remember this. So unique address is 11010000 and read for the write r/w is 0, for the read r/w is 1. Now tell me, if my intention is to write, okay, if my intention is to write, what will be the unique address I should be passing? If my intention is write, it is 11010000 and for write it is 0. So can you give me the hexadecimal equivalent? 0x. Come on, what is the hexadecimal equivalent for the write operation? So I hope it is 0xd0. And what about the read operation? Whenever I want to read, my intention is to read, I pass the unique address 11010001, which is nothing but 0xd0, sorry, d1. Okay. So for the write operation, unique address is 0xd0. For read, it is 0xd1. So observe the macro here. Slave write is 0xd0. Slave read is 0xd1. Okay. Now, first I have to transmit the unique address of the RTC along with the intention. So what do I want to write? I have to first, let me show you here. First, I have to write the unique address. So it is write, hence I am going to call I2C write function. So then I have to write the second register's address. Okay, means I have to tell in what address I want to write. So it is I2C write function. I pass the second register's address. Then the data I want to write. See, observe here. First, I'm passing the I2C write function. I'm telling the intention, slave write. Okay, along with the unique address, I'm telling I want to write. Now, the RTC is aware that the master wants to write. Now, RTC should know in what address master wants to write. So, I'm telling I2C write address. Okay, I'm transmitting the address. In this address, I want to write. So, I transmit the address. Then I transmit the data to be written. And then it is stopped. So, this is how you are writing it into the RTC. Understood? So first I pass the intention here. Let me show it again. So I check if the bus has been idle or not. See here. I check if the bus has been idle or not. Then the start condition. I have to transmit the unique address. So it is the write, I2C write. The next I have to transmit the address. Okay, so that is why I passed slave write. So I transmitted the address. So using I2C write. Then I want to write the data into that address. So I2C write of data. Then the stop. Is this been clear? Everybody, is this been clear with respect to how to write into the RTC? Okay. Now coming to the read function. So even in read, I want to read from the RTC. Let's say I want to read from the RTC. So I take a variable called data initially. Okay. Then I check if the bus has been idle or not. Okay. How am I checking? By calling the I2C wait for idle function. Then I have to start. So start condition. Now see, I am passing the intention as write. You have to understand why. So first I will pass the unique address along with the intention. Okay. Now guys, remember, if I am telling the intention as read, I have to tell in what address I want to read. Okay. In what address I want to read should also be said. Means I have to tell RTC that this is the address I want to read from. So that is the means I cannot tell by using the read function. Okay, directly. First, I will say my intention is write and I will write the address. Okay, I'll write the second register's address. Then I will change my intention to read and then read from the register. Okay, so remember what I have to be doing. First, I have to check the bus idle condition, start. Then I have to write the unique address along with the intention. See, suddenly I cannot start reading. So reading from the second registers is two tasks. First, I have to tell the address. Then I have to read from the given address. To tell the address, it is transmitting, it is writing. So first I will tell the intention as slave write. Then I will pass the address, which is the second register's address. Then repeat start. So if you want, you can start over again by checking bus idle condition, start condition, then check if then pass the unique address along with the intention as read and then read from the register. Okay, so what am I doing? I'm doing the repeat start. Now my intention is being changed. So I'm calling the I2C write function telling that this time I want to read. So my intention is read. So I want to read. I'm calling I2C read function. Whatever is being read, I'm storing it into the data. I stop the communication and return the data. So this is how read operation has been happening. Understood? Understood the read to the RTC and write to the RTC? Everybody, is this being clear? All right. So that is it. We are done. We did the initialization to the RTC. We saw how to read from the RTC and how to write into the RTC. Okay. Now let me come back to the main function. So here in the initialization, I did the initialization of DS1307. Then I have to do the initialization of CLCD because I hope you know that I'm writing the data into the CLCD. Every data means I'm printing after getting the information from the RTC. I'm printing it into the CLCD. So to print to the CLCD, I have to do the initialization with respect to CLCD. So I've done that init CLCD function. Then after that, I'm on the very first line I'm writing CLCD print DS1307 test line 1 zeroth position. So on line 1 zeroth position, I'm printing DS1307 space test. Okay. On the very first line, I'm writing DS1307 space test. Okay. Next, initialization is done. I come back here. Okay. After that, I have to read the time on a continuous manner. Okay, I want to read time. So I want to read seconds, I want to read minutes, I want to read hours. So I've taken a character array by the name clock register of size 3 and passing the clock register array to the get time function. Okay, I'm passing the clock register array to the get time function. So control comes here. Now what am I doing? I'm calling ds1307 read function and I'm reading from the hours address. Then I'm reading from the minutes address. Then I'm reading from the seconds address. And whatever I have read, I have stored it inside clock register of 0, clock register of 1, clock register of 2. So clock register of 0 right now is having the hour in BCD format. Actually, it is having all the 8 bytes from the hour address. So it is having clock register of 1 is having all the data from the minutes address, 8 bits of data from minutes address. Clock register of 2 is having 8 bits data from the second register's address. Okay, so clock register of 0, clock register of 1, clock register of 2. Now, clock register of 0 is having hours, this is having minutes, this is having seconds. I have to display it on the CLCD. What type of value is present inside clock register? What type of value is present in the clock register? Means array of 0, array of 1, array of 2. What type of value is present in the clock register? Come on, quickly. What type of value is present in the clock register? Yes, it is in the BCD format. Now tell me, can I print the data in the BCD format directly onto the CLCD? Is it possible to print the data which is in the BCD format onto the CLCD directly? No, that is not possible. So what conversion do I have to do? What conversion do I have to do? What type of value can I be printing on the CLCD? What type of value should I be printing on the CLCD? Yes, it is character. So BCD to character conversion has to be done here. Let's call the display time function by passing the clock register. So control comes here. Clock register of 0 is having hours. Clock register of 1 is having minutes. Clock register of 2 is having seconds. I have taken a character array by the name time of size 9. Okay, I've taken a character array of name time of size 9. Now, what I want to do is in this time register, okay, so in this time register, I somehow want to store the data like this: 2 digits of hour, colon, 2 digits of minutes, colon, 2 digits of second, and a null character. I want to store like this. In the time register, I want to store 2 digits of hour, 2 digits of minutes, 2 digits of seconds, in between the colon and a null character. Later, I will call CLCD print function by passing time. Okay, so now how to do it? Clock register of 0 right now. Okay, so let's say clock register of 0, okay, is having hours. Okay, this is having hours in BCD format. So let's see how to convert this. So first of all, hours in the BCD format means 8 bits from the address 0x02. See here, hours is in the address 0x02. All these 8 bits are in the clock register of 0. Do you people agree? All these 8 bits are in the address, all these 8 bits are in the clock register array, clock of 0. Do you people agree? Okay, now see here, bit 7 is having 0. Okay, bit 7 is always fixed to 0. So I'm telling what 8 bits is this clock register of 0 having. So it is having 7th bit as 0. So it is having actually 8 bits. Let's make it like this. Bit 7, then there is bit 6, then there is bit 5, there is bit 4, there is bit 3, there is bit 2, there is bit 1, there is bit 0. Okay, I want to know what and all bits have been present inside this clock register of 0. Okay, like this. Okay, so bit 7, bit 6, bit 5, bit 4, bit 3, bit 2, bit 1. So bit 7 is always fixed to 0. Okay, coming to the bit 6. If you see here, coming to the bit 6, it is to select whether it is the 12-hour format or it is the 24-hour format. Okay, how to select it? You see here. Okay, so it can run either in 12-hour or 24-hour mode. Bit 6 of the hours register is defined as 12-hour or 24-hour mode bit. When high, it is 12-hour mode, and when it is low, it is 24-hour mode. Okay, if that bit is been 1, it is 12-hour mode. If that bit is been 0, it is 24-hour mode. And in our case, it is 24-hour mode. Okay, so in our case, we have taken is the 24-hour mode. So this bit is going to be 0. Then the next bit is going to tell whether it is AM or PM. Okay, you see here, the next bit is going to tell whether it is AM or PM. So how is that AM or PM? You see here, the bit 5 is the AM or PM bit with logic high being PM. So if it is 1, it is PM. If it is 0, it is AM. Now, because ours is a 24-hour format, remember bit 5 is the second 10-hour bit. Okay, so the rest 5, all 6 bits I'm using to store the hour. Okay, all the 6 bits I'm going to store the hour. Okay, now how is that being actually stored is first digit. Okay, first digit of the hour is being stored in these 2 bits. Next digit of the hour is being stored here. Okay, first digit is being stored here. Next digit is being stored here. So usually if the hour, let's say, is 23. Okay, let's say hour is 23. So how is it stored is 2 represented in binary. It is 1, 0. Okay, and 3 represented in binary is 0, 0, 1, 1. So like this. For example, let's say it is 19. So here it will be 0, 1, and here it will be 1, 0, 0, 1. That is how the BCD conversion happens. So it is almost like hexadecimal, but you don't see the characters. So there is no characters from A to F. So any digit has been represented in binary as it is. That is binary coded decimal. Okay. So where are the hours? The first digit of the hours is in the first 2 bits. Next digit of the hours is in the next 4 bits. Okay. I have to get it. Now tell me how to get these 2 bits. How to get only these 2 bits? I want to get these 2 bits only. Can you people tell me basic C again? So clock register of 0 is having this. I want bit 5 and bit 4 because that is how I'm going to get the first digit of the hour. Can you tell me how to get it? I want bit 5 and bit 4 only. Come on guys. Have to get bit 5 and bit 4. Bit 3, what is it? Bit 3 to bit 0 have to make 0. Apart from that, I don't know. Right now, we are telling for 23. I don't know what value it is. But I want to get the two digits from bit 5 and bit 4. Have to get it. Nobody knows how to get it. Can I tell? Can I right shift this to the? Can I right shift this for 4 times? So if I right shift this bit 1 and bit 0 left shift by 4 times. Bit 1 and bit 0 left shift by 4 times. In that case, 1, 2, 3, 4. So you will get 1 seen here. Why? I don't know. Why are you saying that? Okay, anyways, I'll do accordingly. So I will do this right shifted by 4 times. Okay, anyways, I'm right shifting by 4 times. So if I'm right shifting my 4 times, can you tell me these two bits come to which position? So let's say it is 0, 0, 0, 0, 0, 0, 1, 0. Now tell me how to get these two bits. I right shifted by 4 times. Can I do AND with 0x03? Guys, this is very basic C. You should be doing it by yourself. Yes. So I have to AND it with 0x03. Correct? Yes or no? Did I end up getting these two bits? Did I end up getting these two bits when I did this? Clock registered, right shifted by 4 times and with 0x03. Now how to make it a character? Goal is bit 5 and bit 4 have to make 1 1. No. Goal is bit 5 and bit 4 has to be obtained. I want to get the value in bit 4 and bit 5. Why will I make 1 1? It is already there. I want to know the first digit of the hours. So first digit of the hours is in bit 5 and bit 4. I have to get these two digits. So now how to make it a character? This gives me 2. I want to make it character 2. How to do it? Can I do plus character 0 like this? Can I do plus character 0? Okay. Now tell me how to get these 4 bits from the clock register. So this I'm storing it in time of 0. Okay, this I'm storing it in time of 0. Then in time of 1, I want to get the, sorry, not time of 0, I guess it is time of 8. Okay. So then in time of 7, I'm going to store the second digit of the hour. How to get the second digit of the hour? I want these 4 bits. Come on, clock register of 0 is having that anyways. How to get the 4 bits? Why left shifted by 4 times and all? They are already in LSB. Can I directly AND with like 0xff? Don't you think this is sufficient? Don't make things, not ff, sorry, 0x0f. Don't make things complex. It is not necessary. I just want to get these 4 bits. So it is clock register and with 0x0f, yes or no? First of all, whenever get bits is what I say, you have to remember it as and only. Do you people agree that you end up getting these 4 bits when I do clock register of 0 and with 0x, sorry, these 4 bits? Do you people agree? Okay. I want to make this a character back. So plus 0. That is what we have made here. See? Clock register of 0. Okay, I have started with index 0 only. Okay, fine. So clock register of 0 right shifted by 4 times and with 0x03. So I am making it a character. Again clock register of 0 and with 0x0f. I am making it a character 0. What should I be repeating, Jyoti? Jyoti Prakash. What should I be repeating? Both these two lines or everything this? Display time function. Okay. Guys, I'm repeating it again. Please listen attentively. So I'm calling first get time function to read the hours, minutes and seconds from the RTC. So I come here, there is read DS1307 function. I pass the address of the hour register to get the hour value, then minute register, then second register. So clock of 0 is having the data from the hour register. Clock of 1 is having the data from the minutes register. Clock of 2 is having the data from the second register. So I have to display the time along with the colons in between. And remember the time whatever I have fetched is in the BCD format. I have to convert it into character because CLCD can print only characters. So I'm calling display time function by passing the clock register. So clock register of 0 is having hours, clock register of 1 is having minutes, clock register of 2 is having seconds. Okay. So now what happens is, I want to know what is written in the clock register of 0. It is having 8 bits of data from the address 0x02. So 7th bit is 0. 6th bit is whether 24-hour format or 12-hour format. So if it is 12-hour format, there will be a 1. If it is 24-hour format, there will be a 0. Ours is 24-hour format. So I have taken a 0 here at the bit 6. Okay, here I have taken a 0 at bit 6. Next, coming to bit 5, it is talking whether it is AM or PM in the 12-hour format. But ours is 24-hour format. So all the 6 bits will be used for storing the hour. Okay, all the 6 bits will be used to store the hour. First 2 bits will have the first digit of the hour. The rest 4 bits will have the second digit of the hour. So hour varies from 0 to 23 because ours is 24-hour format. So bit 5 and bit 4 is having the first digit of the hours. Bit 3 to bit 0 is having the second digit of the hours. So I want these 2 bits. So what did I do? Clock register right shifted by 4 times. I brought these 2 bits to the LSB. And with 0x03, I got these 2 bits. But I have to make sure it is a character. So I did plus 0. I wrote it into time of 0. Okay, I wrote it into time of 0. Then to time of 1, I'm writing clock register of 0 and with 0x0f. I want these 4 bits from the clock register of 0. I am getting it by doing 0x0f and with 0x0f. I want to make it a character, so plus 0. Understood? Okay. Next is I have to add a colon. So time of 2, I'm adding a colon. Then after that, for the minutes, it is something similar. See, first bit is 0, it is fixed. Then the rest 3 bits is having the first digit of the minutes. 4 bits is having the second digit of the minutes. So that I have fetched it like this. Clock register of 1 right shifted by 4 times and with 0x07. Okay, to get the first digit of minutes. This gives me the second digit of minutes. Similarly, I have done it for seconds. For seconds also. First bit is CH, ignore it. The next 3 bits corresponds to first digit of the seconds. Next 4 bits corresponds to second digit of the seconds. So it's the same like this. So both of them are the same. Then somewhere in between I'm adding colon and I'm terminating with the null character. So now time array is ready with hours, minutes and seconds. Okay, correct. I have to start with index 0. So index 0 is having hours, 0 and 1 is having hours, then colon, 3 and 4 is having minutes, then colon, 6 and 7 are having seconds, then a null character. So I'm calling CLCD print function. I'm passing time as an argument and I'm telling print it on line to fourth position. Understood the display time function? Guys, is this been clear with the display function? Okay. So if you can see, I have given build options. Some warnings are there as some function calls are not done, which is okay. So I'll come here. Let me do the reload last. I have already loaded the hex file. So this is not correct. So RTC must have to be refreshed at times if it is not being used. So now you can see it is displaying DS1307 test in the very first line. In the second line, it is 20 hours, 7 minutes, the seconds. That is how RTC is being used. Understood the communication between the microcontroller and the RTC using I2C protocol? Everybody, any doubts? Please let me know if you have got any doubts because this is it. We are done with the I2C protocol and you have got an assignment to be done on this. Everybody, is this clear? Okay, great. Anyways, so that is it about the I2C. The next we have got is the CAN protocol, the last protocol, which I'll be finishing it off in tomorrow's class. So tomorrow will be the last class of your module. Okay, so your module gets over by tomorrow. So meanwhile, let me have the attendance displayed. Okay, so please mark your attendance meanwhile. So as I'm saying, tomorrow is the last class of your theoretical things, means with respect to the module. And from Monday, we are starting with the project. Okay. So tomorrow is the last class. We are finishing off the CAN protocol and we are done for the modules explanation. So there's no class on Saturday and we'll be reaching out back, not even on Monday. Monday is a holiday. So we will be meeting back on Tuesday for the projects explanation. So we'll do 50% of the project in class. So it's a code along session. As you must have observed in C programming, advanced C module also. Here also we have got code along session and we'll be doing 50% of the project in class. And for that, all of you must have to be responding for sure. If you are sitting silently and just listening is not going to work. So it's a lengthy project. Trust me, almost most of the peripherals will be included in that. So please make sure you are revising and then sitting for the project's explanation. Tomorrow will be the last class and I am going to be finishing off the CAN protocol. Okay, so that is it for today. I hope the class has been clear. If you have got any doubts, you can ping me up anytime. And please mark your attendance. Once you are done marking the attendance, you can quit the session and we'll meet tomorrow as usual. And we will be discussing the last topic, which is the CAN protocol. Thanks for attending the session. We'll meet tomorrow. I'll wait for a few more minutes until everybody is done marking the attendance. Please utilize today's time to finish off your pending works. Thank you all. We'll meet tomorrow. If yesterday's attendance is not marked, I'll check, Jatin. I'll check and let you know.